Hello, algebra people. I hope you are well. It is time for a little bit more algebra. Hello from me, Miss Waite. I hope you're having a good day. Here's a warm-up for you. Best strategy for warm-ups is to pause the video and try this problem on your own first. You don't really have to grab graph paper if you don't want to. You can just think your way through this. What would the graph of x equals 5 look like? And then I'll be back in just a second and we'll talk our way through it. Alrighty, here we go. So when you are asked to graph x equals 5 or any equation, it means that you're trying to draw a picture of what that equation looks like. That's essentially what we're looking at here. So graphing x equals 5 is going to require some graph paper and some numbers on a grid and all this kind of stuff. And so you see that in front of you. When you want to graph x equals 5, the last time we talked, we talked about how there are a couple of kinds of lines. Well, there's actually 4 kinds of lines. Lines that slope up from left to right, lines that slope down from left to right, and then also horizontal lines and vertical lines. And horizontal lines and vertical lines have these nice little tiny equations where really you just have to remember which is which and then draw the line at that value. So whenever we have a horizontal line, that's going to be y equals something. And whenever we have a vertical line, it's going to be x equals something. And so you just draw a vertical line at the value that is right here. 5 in this case. And so I'm going to find 5 on the x-axis, 1, 2, 3, 4, 5, and then I'm going to draw a vertical line through it. And that is the graph of x equals 5. That's it. It's done. Yeah, things are going to get a little bit more tricky, of course, and we're going to add pieces to these equations and make it a little bit trickier. But for now, that's really all you have to do. Okay. So time to update that notebook, pause the video, write questions for your last set of notes, write a summary for the previous set of notes, and if you want to today, you can just add to your notes. If you want to start a new page, that's great. But if you want to, you can just add to your notes. No need for a new page today because today is a review. You're going to be having a quiz tomorrow. So today is a video to watch to make sure that you know how to do well on the quiz. So this is the kind of stuff that's going to be on the quiz. Stuff about functions, being able to identify linear functions, graphing using a table, graphing using intercepts, and graphs of horizontal and vertical lines. So today we're going to review these ideas in order to get ready for a quiz. Now I'm going to pause this real quick because my phone is dinging. I'll be right back. All right, here we go. Let's start with functions. So functions are kind of this big idea that you have seen a bunch of times and maybe didn't even know it. Every time you looked at an input-output table or a graph or a set of ordered pairs or a point, you have actually been looking at a function. Functions are a specific type of thing, mathematical thing, where when you put an input into that function, it spits out an output. So if you put a number into a function, it'll spit out another number, and that's why you can describe a function with an equation. You've done that in this class. You've put a number into an equation and calculated a little bit and got another number at the end. You found out the value of that equation. That's because that was a function. You can have an input and an output, exactly one output. Also, we've looked at tables, we've graphed from tables. We haven't done a whole lot of using words, but basically that's this idea right here. You can describe a function by saying it's a relation where every input has exactly one output. In other words, it's very predictable. We can also take a look at a function in a graph This is just one type of function, this one here that you see on the right. And you can also look at it as a set of ordered pairs. In other words, these ordered pairs would be a function because every input, the 1, the 2, and the 3, has exactly one output. Okay, so that's kind of what functions are. We need to be able to recognize when we have a function, and there's a number of different ways. First of all, this input-output table. Now the trick is, what you're looking for is in this input area, I'll put a star in it, in that input area there, is there more than one? I'll say it this way, is there a repeat? Because if there is, then you don't have a function. So this -2 doesn't have, nowhere else across this whole input line is there another -2. So far, it's a function. When I look at -1, I can look around in those inputs and there is no other -1, and so it's still a function, but look at the zeros. See how if you input 0, you could get a 5, or if you input 0, you could get a 6. This makes this not a function because it's not predictable. That's the thing about functions. You have to be able to put one thing in and get one thing out. You don't want to have a situation where you put one thing in and then you're not really sure which one you're going to get back. In this case, you could get a 5 or you could get a 6 when you put in 0, and so that makes it not a function. Now, this one here, I guess it's marked D. These are another way of having input-output information. Notice that -1 has one output, 4. Notice that 3 has exactly one output, 15, and 11 also has one output, 15 as well. Now it's okay that these inputs, the 3 and the 11, go to the same place. That's okay. They still have just one output each. And so yes, this is a function. Now look at how different this is from part C, the other part C. 1 goes directly to 8, 2 goes directly to 9, but look at 3. When you input 3, you might get 10, and you might get 11. And so this is where you have not a function. Okay? So if there are 2 arrows coming out of an input, that's not a function. If each input, like in this one, has one arrow, then it's a function. Okay, another way to tell a function is by the horizontal line test. Do you remember that? Where if you can draw vertical line test. Vertical lines through a graph, and no matter where you draw that vertical line, an infinity of them, it will only cross that graph in one place, then yes, that is a function. It passes the vertical line test. So let's see if we can do that with this one. Well, through that dot, I can only pass a line once, just one dot on that line, one dot on that one. I'm trying the vertical line test, but look what happens. 1, 2. And so it does not pass the vertical line test because there's 2 dots on that line, and we're done. That's all we have to know. So these are different ways of being able to identify functions, being able to tell if an object is a function. I'm going to have to pause this again. All right. So then we started talking about linear functions and whether or not we could tell if something was a linear function. And the idea is, well, pretty much if it's a line, it's a linear function, and if it's not a line, it's not. So this part A, no, not a linear function because it's not a line. Part B, yes, that's a line, so it's a linear function. So then let's take a look at what happens with tables, and that's a little bit trickier when you're trying to figure out a linear or non-linear function. And the thing with tables is that it's all about consistency. You just want to have the same difference every time. So jumping from 0 to 1 up here is sort of like adding 1. 1 to 2 is adding 1. 2 to 3 is adding 1. And then we look at the bottom. 3 to 5 is adding 2. 5 to 7 is adding 2. 7 to 9 is adding 2. And because this row is the same as each other, and this row is the same as each other, this is a linear function. Now let's look at this one over here. When you're going from 1 to 2, that's like adding 1. Going from 2 to 3, it's like adding 1. Going from 3 to 4, it's like adding 1. That's what you do to get to each step. So far this looks like a linear function. But let's look at what happens when we look at the bottom. Going from 16 to 8, you had to subtract 8. Going from 8 to 4, you have to subtract 4. Going from 4 to 2, you have to subtract 2. And since these numbers are different numbers, not a linear function. Linear functions are consistent. They're predictable. They're not going to change. Everything about them is going to be, well, consistent is the best word. Okay. Then we started talking about graphing using a table, and this is kind of a messy way to graph, and we're going to move away from this pretty quickly, but you can use a table to graph just about any equation, which is why I teach it to you, because if you forget all the other tricks that I'm going to tell you, then you can always fall back on this. It's messy, but you can still do it. So we want to graph the equation y equals 2x plus 2. In order to do that, we need points to plot on this graph you see over on the right, and then we will connect those points with the line that they suggest. So in order to get those points, we need x values and we need y values. So let's make a table and we'll find some. So we're going to choose some x values. These are going to be our inputs. We're going to input those guys into this equation, and then it's going to spit out some y values for us. And you can do 3 or 4 points, and that's really enough. I suggest doing at least one negative number, 0, and maybe a couple of positive numbers. And they don't have to be big. Don't be throwing like 3 million in there, because that's just you're working too hard. You don't need to work that hard. So you're choosing your x values, and then you're going to drop those in right here, and you're just going to do that for each one of those values. So for the first one, we have y equals 2 times negative 1 plus 2. Well, 2 times negative 1 is negative 2, plus 2 is 0, and so we know our y value here is 0. When x is negative 1, y is 0. Now let's do it again for 0. We're going to say y equals 2 times 0 this time, plus 2, and that's going to equal 2 times 0 is 0, plus 2 is 2, so when x is 0, y is 2. Now we'll do it again with the 1. Y equals 2 times 1 plus 2. See why you use small numbers? Because you can just kind of do it in your head. 2 times 1 is 2, plus 2 is 4. And so when x is 1, y is 4. And the last one, y equals 2 times 2 plus 2. Well, let's see. 2 times 2 is 4. 4 plus 2 is 6. And so when x is 2, y is 6. And now we have x values and y values that we can plot. These are essentially points. We can use the point negative 1, 0. And so we're going to go out to the left 1, and then nowhere up or down, and that's where that first point lives. It's going to be on that line. Here's another point, 0, 2. So we're going to go nowhere left or right, but we have to go 2 units up, and so that's where our point goes there. And then 1, 4 is also on the line, so we're going to go 1 unit to the right and 4 units up, 1, 2, 3, 4. You start to see the line forming, and then we want to go out 2 to the right and then up 6. 1, 2, 3, 4, 5, 6. There it is. And that's really enough for us to be able to tell that the graph of this line looks like this. So really, it's just a matter of choosing some values for x, throwing them in the equation, getting the corresponding values of y, plotting them, and connecting them with a line. Be sure you put arrows on either side of your line. That's how you graph using a table. And then we started talking about the idea that, well, graphs cross the x and y axis, and when they do, this is a really nice, predictable way in order to graph these lines. Now, we don't know anything about their equations yet, but that's okay. Really, all we need to know is where they cross the x and y axis. What this part means right here is that this line crosses the x-axis at -5, and so we can put a dot right here on -5 on the x-axis. And then we know it crosses the y-axis at +3. So 1, 2, 3, there's a dot on the y-axis, and then all we have to do is connect those with a line. Oh, it's the worst line ever. And there you go. If you know the intercepts, just plot them, throw them down on there, connect them with a line. So this one says that it crosses the x-axis at 2, that's right here. And this one says it crosses the y-axis at 3, that's right here. And then there's your line. Done. When you know the intercepts, it's pretty simple. Just put those dots in, connect them with a line, and you're done. And then the last thing we talked about, which is very much like the warm-up, is graphing horizontal and vertical lines. This is sort of our first step into having the equation of a line and being able to graph it. That's where we're going to kind of stay for the rest of the year, is how do you graph equations of lines. And this is our first step. When we have little tiny equations, y equals something and x equals something, they're either horizontal or vertical lines. Horizontal means flat, going from left to right, just like the horizon, and vertical is the other one, going straight up and down. Y, what am I saying? What I guess I'm saying is, when the equation is y equals something, that's your vertical lines. When your equation says x equals something, some number, those are your horizontal lines. Okay? So y equals 3 is a vertical line at 3. Well, we find where, remember this is the x-axis and this is the y-axis. Let's find where y is 3. Well, we've got 1, 2, 3 right here. And then we know that's going to be a, sorry, I got that wrong. Oh, you guys, no wonder. Y equals is horizontal. I hope you caught that. And x equals is vertical. My bad. So sorry. Y equals 3 is a horizontal line at 3 on the y-axis. That's it. That one's done. And then we also have x equals -5. So we find where x equals -5, 1, 2, 3, 4, 5 right here. And then we draw a vertical line. And that one's done. Both of them are now graphed. Okay? That's it. You are going to be just fine. Don't hesitate to ask for help. You know, on Google Classroom, on the classwork page, there's a little link that says need help. Click it. There's like 6 different ways to get help with this stuff. Algebra is really hard sometimes and can be really confusing, but I guarantee you with a 5-minute conversation, I can clear a lot of things up and you'll be doing so much better. I promise. You got a quiz. Actually, it says quiz on Monday, but you're getting it tomorrow, so don't pay attention to that. And that's okay. You can do it on Monday if you want to. Anyway, I hope that you have a good day. If you need some help, please do let me know. You can do this. I know you can. Have a great day. Bye.